For anyone just joining us, here's the beginning of section 1.2, homework number 2, as we grade the evens. If you need a little more time, feel free to pause this video and check out as you grade. Number 4, number 6, number 14, A is yes, B is no, because of the true and false statements corresponding to those answers. Number 22, 42 and 43 we'll come back to in just a moment. Number 48, with both the intercepts, the symmetry, there is none in regards to the y or the x or the origin, possibly with regards to the parabola itself, but not the 3 that we're used to. 51, something went wrong in, I believe, CalChat, maybe the back of the book as well, and so here's the solution. And 55. Now we're all caught up. Tony, what'd you find? Was it good in the back of the book or no? Okay. So just in case you needed the worked out a little bit more, but in the back of the book you guys should have been fine. As far as the intercepts and then the x-axis symmetry. Are you guys getting used to the plus or minus square root and making sure you get both whenever you have to take that square root? Okay, good. Then we have our function. Number, who's this guy? 65. I know it's very rare that I have odds, but there must have been something funny, whether with CalChat or somewhere else. Just check it quickly, make sure you're good. Number 74, you had to, I believe, find the radius. I see a little distance formula going on. The radius should have been 5, and then you plug in the center, not the solution point. The solution point is a point on the outside of the circle. You could have used it for distance, but you can't use it for center. Only the center can be the center. And there's our final equation. And I believe, oh, nope, we have one more. Number 82. Something weird? Okay. Number 82, you could have pulled out the h, which is positive 2, the k, which is negative 3, because the formula is y minus. And the only way that changes to a positive is if you had a negative. Radius, you have to square root in a fraction, the top and the bottom. 4/3 times 4/3 is 16/9. So then you could have drawn in your graph approximately 1 1/3-ish all the way around. You would have had that guy just fine. Now I think, oh. We'll get back to number 85 in just 1 second. Let's go ahead and go check out the 2 that we skipped, which I believe was numbers 42 and 43. Okay, let's go see what was going on with those. 42 and 43. I think the answer key was just having issues on this homework, which is why it was easier for me just to kind of leave these ones off and have us come here. All you were supposed to do was start with this graph and complete it. It was kind of like finish the picture. Just nothing was like traced for you just to kind of go over. Finish the picture if this graph does have x-axis symmetry and this is a portion. What's the other portion going to look like? Yeah, just complete it, right? So you should have just completed number 42. And then number 43, where did you copy this portion of the graph? Just because every now and then a couple people make a few mistakes. X-axis symmetry. This guy should have just kept going. Roughly, pretend that's the same. And then this guy, did you guys have a little W? If you didn't have a little W, double check it and fix it. Because you needed to have, wait a minute, what symmetry is this? What symmetry is it?
Origin.
Well, that's what it needs to have. What symmetry would this be?
Y.
Okay, so we don't want y-axis symmetry. So origin symmetry. Did you guys go up, and then down? Like a weird, funny cubic function? Technically hitting at the point. Ooh, that's not quite right either. What point should it hit at? Good, negative 1, 0, right? So it should just have a little baby one. There we go. That's a little better. Origin symmetry. It flips over and down. So the over would have been the W. That would have been y-axis symmetry. But it also had to flip down. So that little Humpty Dump is going to be in the opposite quadrant, like 180 degrees away, not the fourth but the second, not the first but the third. So they had to repeat, copy each other over there. Whoop. Wow. Technology, love it. Nope. Well, this is a party. Okay, at least this button still works, even though my mouse no longer does. Any questions up to 82, evens or odds? Not 85, not yet. Any questions up to 82, evens or odds? You don't have a lot of time. You should be able to find your question marks fast, or I had to mark something wrong and I don't know why fast. Kyle? 74. Anything else besides 74? Ooh, it's working again. Okay, number 74. What would have thrown someone off? What could have thrown someone off? Solution point. What does it mean as far as a solution point? Does a circle actually, the graph of a circle actually include a center? No. A circle includes all the points on the outer edge of the circle, right? So when it says center, that's good. It's telling you what it's centered around, which we need for HK. But a solution point is a point that is on the circle itself, aka a point on the outside. So then if we were to go ahead and sketch this, just giving you an understanding as to why the book did what it did, why the solution is what it is. Is it this guy right here? It is, right? Yeah. Okay. 74, right, Kyle? Okay. The center. Got it? Not actually a part of the circle, but it is quite important as far as our reference point. But negative 1, 1, awkwardly up here. So if I were you, and if you had a compass, you would put the pointy end right here, you would put the pencil end right here, and then you would go around. Equation of this. Well, don't we just plug in? But what are we missing? R squared. Because we can plug in this guy, no problem. We can plug in this guy, no problem. We just need R. Well, how do we find R? What's the distance? So in the distance, I'm going to use my cool triangle way. If this guy's over 3, 3 and 1 makes 4. If I go up, 2 and 1 makes 3. So R is going to equal the square root of 16 and 3 is, sorry, 16 and 3 squared is 25. And the square root of 25 is 5. Finish that puppy off and you got it. All right, anything else, evens or odds, up through and including 82? All right, who had a question on 85 in some way, shape, or form? Okay, that's why I left him for last. That's why there's already a copy of the problem right here. Ironic thing is, he's really not that bad. So you guys got scared for nothing. Never mind. Okay, now it's going. Cool. I'm going to go ahead and quickly just move this guy off to the side. Scroll the problem, maybe zoom him in just a little bit. Let me get some white space, just so I have some room to work. And nothing, huh? Now it decides to be complicated. Okay, so for this guy, can I fit them all? Got it. A regulation NFL playing field has the shape of what? I'm not going to do the whole thing. You guys don't need me to. You're honors. But hopefully we all at least did this. Did you have to label it this way? No. What else could you have done? YYXX, BBHH, LLWW? I don't know. Why did I use X's and Y's instead of lengths and widths and bases and heights? We kind of told you down here you better have some X's and some Y's. So okay, all right, fine. X's and Y's. What clue do they give you besides the fact that you have a, length of X and the width of Y, maybe we should use those? What other clue is in this information at the beginning that should be written in your homework? The measurements. And what was, it's hiding right now, but you should have it right there. What was 1,040 over 3 or 46 and 2/3? Yeah, Austin. Good. So perimeter is equal to, now why am I, first of all, writing it as an improper fraction? Life is easier. Not for visualizing how big it is, but for just working with it as a number. proper fractions so much easier most of the time. But why did I leave the big old blank space? We have a rectangle. We have a perimeter. What should we know about perimeter and rectangles? 2x plus? It's the distance around. That's just geometry. Perimeter of a rectangle is 2x plus 2y. Now, letter A just says, hey, draw. Sweet. Letter B says, show that the width, wait, who's the width? Y. Has a formula of, wait, where's my y? What did we do yesterday when the circle was all like in this formula and the x's and the y's were all like together on one side of the equation? What did we do to put it in the calculator? Got y by itself. What's going on when it says show that this is true? All they did was get y by itself. Thought you guys would fill in a little quicker. It's all right, we're working. All they did was got y by itself. Perimeter has a formula for a rectangle. They told me what it's equal to. Sweet, just get y by itself. How do you do that? Well, I don't know. Subtract 2x, you guys agree? Now what? Divide by 2. What's an easier thing than, multiply by 1/2 sounds a lot better, right? Multiply by the reciprocal or multiply by 1/2. It would do the exact same job of getting rid of the 2. Just make it a little bit easier. So if I multiply by 1/2, this is a binomial, right, guys? What do I do if I multiply the whole thing by 1/2? Good. So I end up with 1,040 over 6. Wait a minute. I think that these reduce, right? Wouldn't that just be the same thing as 520 over 3 minus x equals? I think that's just what they had right there. Oh. Dun. Dun, 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 dun. And its area, oh, it's just getting mean now. Wait, area, rectangle. What's area of a rectangle? Base times height. So if area of a rectangle is base times height, then couldn't we say, who's the base of that rectangle in the picture? X. Who's the height? But who's y? Oh. They're just having me do what I should have known to do anyway from geometry and using the clue they gave me of that perimeter being 1,040 over 3. Now we've gotten a really snazzy equation in terms of just x's, and they say, graph this thing on a calculator. Wait a minute, there's no place in your calculator where you can write a equals. But if you're using the graph, you're just going to say instead of a equals, what are you going to set a equal to? It's the best you can do. Make a y1. It's not a y value magically. It still stands for area, but it's the only thing we can do in our calculator is putting it in the y1. All right, fine, put it in your y1. And what's it asking you to do with this y1 equation that really stands for area? Graph it and get a nice window. So letter C is just going to show a sketch. If you guys are algebraic thinkers, if you were to distribute this x, isn't this a downwards facing parabola? Because of the negative x squared? Well, you could. Like, it'd be the same equation, but I don't know if it's going to make it so that you can mental math the graph. Like, you probably want to use your calculator. Yeah, you're going to have to zoom out a lot. Because of this 520 over 3, right? Because if you think about it, what would your intercepts, that might help you with your window. What would your intercepts be for this guy? Your x-intercepts. You would set who equal to 0? Y equal to 0. What do we do when we have factors equal to 0? What did we do yesterday when we had y-intercepts trying to find the zeros and we factored? We set each one equal to 0. So wouldn't your intercepts be 0 and 520 over 3? And isn't 520 over 3 roughly 170? Yeah. So you might need to make your window a lot bigger and have the x max go to like 200. then you might need to make your y max if you're doing it manually. Or you could just zoom out, zoom out, zoom out.
Is there any way to tell for the y axis?
You can go halfway in between 0 and 170-ish because the vertex always happens halfway. There's that symmetry. So halfway between 0 and 170-ish is what, 80-ish? And you could plug 80-ish into the y equation, or I should say into this equation. So what would 80 be times 170 minus 80? 80 times 80 would be 6,400. So you would need to go up to like 10,000. Now, why am I having you get a nice picture? Well, letter C says sketch, or get a nice picture, but sketch it to show that you did it. And D says find the max using your calculator. Austin. Hold on, what's your window though? What's your X max right now? Oh, it is? Your X max is?
Like your y.
Okay, let me see your y equals real quick. I'm thinking for some reason you don't have a parabola. Weird. $520/3 times x minus x. You have the squared. Should be a parabola.
Yeah, that's what happens when you don't zoom out a lot.
You can do the 10,000. It might just be that like it's squished together, because it actually is only supposed to go up to 170. So I think you've actually squished it really close. Let's see if this makes any difference. There you go. So what you were looking at, it just looks so squished together, and all you saw was this down here. You didn't see that at all. Does that make sense? So I would probably have zoomed out some more. So it wasn't bad, but you didn't need quite as big a range. Like this will make it all nice and pretty and spread out. But you were missing that part. Okay, sorry. Anything else on calculators? Yeah. Well, see how there's a blue line there and a blue line there? You have a parabola. You just need to go way higher. So 800 is good, but we just figured out like halfway between 0 and 170 is 80. We plugged in, it's 10,000. Well, what was it, guys? 64,000?
Yeah.
Or 6,400? I think that's right. There you go. Yeah. So you were only seeing little bits and pieces of it. Keep playing with your windows, keep playing with your calculator, but D was to find the max, and E was to, using the school library. Don't do that. I don't think we have anything about an NFL regulation playing field, but to figure out what the actual dimensions are of an NFL playing field. Who has it? Oh, we could have done that too because it was an odd. That's true. And that is using the internet, technically. All right. Are we good? I don't know about the question, but okay. Anybody have any other questions on homework? Going once? Going twice. Sold to section 1.3. Here we go. Sold to section 1.3. I'm going to pause the video just for a second. Let's talk about linear equations of two variables. What? We're talking about lines. When did you first learn about lines? Algebra 1. Should this be a big deal? No. But have we noticed that topics that seem pretty easy can still stump us a little bit in homework? Have we realized that can be true sometimes? Okay. So let's just make sure that we have a good foundation, and that way when you get to homework and maybe it makes you think a little bit, hopefully it won't be too hard. Too hard. All right, section 1.3. How many of your parents are coming tonight that you think of? Oh, quite a few. Cool. If any of your parents aren't coming, it depends on whether there's time after the whole night's through, but I'll send out in RenWeb through the parent email contact information, the PowerPoint I go through, so if they want to peek at it. If they aren't able to make it, you can let them know it's coming. And they should have turned in their parent form, so I should have their email addresses too. Maybe I'll just send it with those. Maybe I'll do both. We'll see. Okay, here we go. Equations of lines. So I told you guys to skip all these spaces. I'm going to quickly get rid of the spaces just because, I don't know, they're kind of messy. Let's see if the right button works. There we go. All right. What are some different forms of lines that you guys have learned along the way? What's the easiest one? No. Forms of lines. Or give me an equation for a line, like a standard form equation. Y equals mx plus b. Now, actually, I said standard. That's kind of awkward because that's not the name of this guy. Do you guys remember the name of this guy? Slope and intercept. Good. This is slope-intercept form. Why? Because what's in there besides y and x? Who's m? Slope. Who's b? There you go. It's called slope-intercept because there's a slope and there's an intercept. What kind of intercept? Y-intercept. Good. What kind of intercept? Y-intercept. For a linear function, all you need is a y-intercept and a slope to graph it. But not every line has a y-intercept. That's interesting. Another form. I did say just a second ago standard form. That was a bit of a mistake because technically there is a special form of a line that's called standard. Sometimes in math it's hard because I can use a word in like the English sense. What's standard? Like one that you normally go to. But the standard form you go to is slope-intercept. That's awkward. So sometimes a word has a meaning in English and a meaning in math. I'll try not to get too confused or confuse you too much with that stuff, but I apologize for that slip. What is the standard form of a line? Do you remember? There you go. AX plus BY is C. Why don't we like that form? Y isn't by itself, and since Y isn't by itself, who's M? Not A, not B, not C. True. Who's B? Not A, not B, not C. True. Struggle. Now, we could technically find the M and find the B, because M, you're always going to subtract the AX and divide by B, so M will always be negative A over B. And your little b will always be the C over B. But the awkward thing is, isn't it easier just to get Y by itself than to memorize what getting Y by itself gets you? I think so, but technically there is a way to memorize and there is a way to get M and to get B. But technically we would just normally say change it to slope-intercept form, get Y by itself, the math is easier, and then you see your M, you see your B. But there is one other form of a line that you guys probably like the least, even though I think standard form should be the least liked form. But this is actually the most important form for calculus, because he's the most versatile. Why is it nice to have something that's versatile? You can use it in lots of different ways, lots of different instances, lots of different applications. And that's going to be most helpful for calculus. But coming back, what is this form? I started hearing it. Y minus?
Y1 minus y.
Close. Y minus y1.
Equals x.
Whew, there we go. A little brutal. Let's talk about point slope form for a second, though, because what's the equation for slope? Rise over run, which is the same thing as? There's some different notations for that. You could make that rise over run. That's totally fine. You could also make that delta y over delta x, change in y over change in x. But what do you notice about the equation for slope and point slope form? There's no y2, but otherwise, aren't these super stinking similar? Couldn't you just multiply the change in x's over to the other side and basically, if you take out the 2's, have the point slope form? Maybe that gives you at least a little bit of a strategy as far as how to study. Maybe that gives you at least a little bit of a strategy as to how to study. Okay, so what are we missing? We have the slope formula plugged in. We have the equation for the slope, at least somewhat shown. Special slopes. What do you guys think I'm thinking of? Special slopes. What's so special about some slopes? mean, you can have positive numbers, you can have negative numbers. There are rises over runs, but that's the equation for slope down below. What's so special? Maybe I should put it this way. What are some special lines? Unique, tricky, different. What are some special lines? Straight lines? Ooh, careful. They're all straight lines, but I think I know what you're saying. Who can think of what Tony just said and be like, oh, I know what he means? Perpendicular to the... It's a little more complicated than I would have thought. But yeah, what's true about any line that's perpendicular to the x-axis? No, not perpendicular to the x-axis. That means 90 degrees, right? Slope would be undefined. What kind of lines have undefined slopes? Constants? No, but you're close. We're trying to think of, I was just thinking of a name. I was thinking of perpendicular and vertical. That's what I was thinking of. Sorry, horizontal and vertical. I was stealing perpendicular from Tony. Horizontal and vertical lines. And I think you guys, that's the lines you were thinking of. I think you were thinking of like the, and I get that, but I was just trying to be a little more general. So vertical lines and horizontal lines. All vertical lines, Tony, are the ones that are perpendicular to the x-axis, right? Or parallel to the y-axis might be an easier way of thinking about it. So all vertical lines. We've already talked about the slope is going to be undefined. And if the slope is undefined, can I even do like a y equals undefined times x? So there is no y equals for vertical lines. Vertical lines, the form is always going to be x equals. I couldn't just take constant because I need to know who was the constant. So if x equals a constant, that's a vertical line. Horizontal line, what's going to equal a constant? Yeah. Y equals a constant. And the reason this one actually makes more sense to me in some ways than the vertical. Because what's the m of a horizontal line? 0. So then go ahead, well, pause. If we have a slope of 1, you'd be going up 1 over 1, up 1 over 1, up. That's a diagonal line. Okay, so y equals 1x. But what happens if I take slope-intercept form and plug in m equals 0? Y equals 0x plus b? Oh, it's a y equals, but there's no x because there was a 0, so the x went away. So I have two different forms. I have, or I should say, two different formulas for vertical lines and for horizontal lines. My silly way of remembering, even though it seems like some of you guys already have it down, is can you ski if the slope is horizontal? I mean, you can. It's cross-country skiing and without any, anyway, it'd be pretty boring. But yeah, snowshoeing, sure, let's call it that, basically, right? So we're just walking, we're just going, right? You can go horizontally, but what's your slope? 0, that's why it's boring. It's like, all right, fine. There's no slope, but I'm going. Can you ski a vertical slope? You'll be undefined real quick. Anyway, so, you'll be undefined real quick. Go team. Okay, anyway. So you can do the horizontal. There's no slope. It's not up, it's not down. It's just, well, that's flat, right? But that's not flat. That's not flat at all. That's the opposite of flat. I'm going to die if I don't have a parachute on, right? So that's undefined slope. Technically, we would call it infinite slope. That's kind of fun. Why is it infinite slope? If you think of a slope of up 1 over 1, up 2 over 1, up 3 over 1, up 4 over 1, 5, 10, 100, 1,000, a million, a billion, a trillion. Purely straight up and down is infinite slope because slopes will approach to that straight up and down. Anyway, cool beans. Go team. Lines. What else do we have in this section? Parallel and perpendicular. So Tony, we were getting there. Just not quite yet in the last page. Relationships between slopes. That's where parallel and perpendicular comes in. Relationships between slopes. Parallel and perpendicular. Parallel and perpendicular. parallel. We could talk about how in geometry parallel lines will never intersect. Ooh, lines in the same plane that never intersect. You can have skew lines that also never intersect, but they're different planes, not parallel. Skew. Anyway, parallel, same plane, never intersecting. Why are they never intersecting? Because they have the exact, what's the clue? Same slope. I didn't write the word, I apologize. Parallel. Two lines that are parallel have the same slope. Same slope, so that means that M1 has to equal M2. The slope of one line has to be the exact same as the slope of the other line. I guess that makes sense. So if they give me a linear equation and they say, hey, make another line that's parallel to, well, it's going to have different points on it probably, unless I guess the lines are on top of each other. That's awkward. It's going to probably have different points that get plugged in, like a different intercept, but M, steal the M from the first and put it in the second. They're the exact same. Perpendicular, though. What's it mean to be perpendicular again? Hitting at a right angle, good. Intersecting at a right angle. Parallel lines. Intersecting at a right angle. And it doesn't necessarily have to be like this, where one is 0 and one is undefined. What if I was to take this whole picture, and what if I was to rotate him? They're still perpendicular. This guy's slope is negative. That guy's slope, to be perpendicular, has to be positive. So number one, we're going to say that the slopes need to have opposite signs. And that guy's going, say, down 1 over 2. This guy's going up 2 over 1. They will be reciprocals as well. Opposite and reciprocals. Now, some of you forget what these two words mean. Ran out of room. Struggle. Let's move him over. Okay. Opposite, that's talking about the sign. Reciprocal, that's talking about flipping the number. 4 becomes 1/4, 2/5 becomes 5/2, 1/4 becomes 4, etc. You have to change two things with the slope. So we could say if you have one slope, let's say we're given M1, M2 is going to equal negative 1 over M1. You're going to not only change the sign, what's positive becomes negative, or what's negative becomes positive. Not only flip the sign, but also flip the fraction. Opposite and reciprocal. So looking down below, we have one line that they gave us information for. Our reference line is going to be 2x minus 3y equals 5. And then our point on a new line, or actually two new lines, is going to be 2, negative 1. So this is the point, and this is our clue for the slope. It doesn't actually give us the slope necessarily outright, but we're going to use this line. He's going to be our reference, the one that the new line is going to be perpendicular to, or that the new line is going to be parallel to. I need to use that point. The point is established. That's my x1, y1, but how can I use this equation, his slope, to give me what I need for parallel and perpendicular? What do you guys think the very first thing is that we should do? Yeah, get y by itself. Makes life so much easier. So if you guys don't mind, I'm going to do it pretty fast, and we're going to end up with 2/3 x minus 5/3, because you subtract the 2x and divide by negative 3, which distributes to everything. Maybe some of you need to go back and peek at that and make sure you understand why that is what it is if you can't mental math it. But long story short, my clue slope is going to be, or you can think M1 is going to be 2/3. Now it's time to figure out M2s. So first of all, if I was to use or need the parallel, my clue being same slope, what form of a line do you think I'm going to use? Y equals mx plus b, y minus y1 equals m times x minus x1, or ax plus by plus c? Slope intercept, point slope, or standard? No. Mx plus b is slope intercept. I said no to that one. Nope. Why do you guys avoid the most important, most useful one? We have a point. We're about to get a slope. What should we use? Got it. Why? Because you can be given any point, not just an intercept, any point. It's a glorious form because we can go ahead and say, sweet, we know the y1, x1. y1 is -1, so y plus 1. x1 is 2. Got it. M is for parallel. What am I doing with this guy? Keeping it the same. You could go ahead and simplify real quick. Y plus 1 is equal to 2/3 x. Don't forget to distribute. Minus 4/3. 2/3 times 2/1. To add, I apologize. Subtract the 1 to the other side. Why am I writing -1 on one side but -3/3 on the other? Any ideas? That's a whole lot. Go to combine. Dun, 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 dun. What's going to change when I go to do perpendicular? Yep. But I can still do my y, hold on, plus 1 equals x minus 2. All that changes is -3 halves. What's the dot, dot, dot for? Simplifying. Oh no, we had so much more to. Just kidding. Homework due tomorrow. Bye. See you later, alligators. Homework number 3. Keep it up. Have it turned in by 7 a.m. It's in Google Classroom. Happy Tuesday. Thursday. We don't want